think of this video as kind of a guided practice where we'll talk through things, but it's mostly like some extra homework. Oh, sorry, I shouldn't say the H word. Extra practice, extra learning for all of you. Okay, so let's do an example. Let's say that C is the set of 1, 2, 3, 4, and 5. Let D be the set of odd numbers, 1, 3, 5, and 7. And let's say our domain of discourse here is N. Remember, N is a set of natural numbers, the integers from 1, but only the positive ones. Okay? So these are the things that we're going to work with. And I want you to find the following. I'm going to write everything down. I want you to pause the videos. I want you to do them on your own and then resume, and I'll talk through them. Or you can skip ahead to just see the answers. Remember, these are videos, not an actual in-person thing. We're not in a Zoom meeting right now. You can pause, you can skip, you can rewind, you can fast forward, you can walk out of the room. Please don't do that, but you could, all right? Anyway, what do we got here? So I want you to find out what is C union D. What is C intersect D? What's the empty set union D? What's the empty set intersect D? What is, let's see, C union omega? C intersect omega? What is C minus D? What is C complement? And lastly, this will not fit easily. What is C cross D? I think that's the main things I wanted to ask here. So yeah, go ahead and pause the video and see if you can fill all these out. All right, so remember, union is what's in either. We put the sets together. We combine the sets together. Sets have no order, so the order doesn't matter. I like to put them in order, but that's just me. It makes things easier for me to read. They're the same set though, either way. So it's just going to be 1, 2, 3, 4, 5, and 7. In fact, almost everything in D is also in C. So 7 is the only new thing here. Intersect is their overlap. What's in both sets? Well, 1, 3, and 5 is what's in both sets. So 1, 3, and 5 is going to be our answer. Now we get to some weird things that we didn't talk about in the last video. What is in the empty set or D? What's in either or both of them? Well, there's nothing in the empty set. The answer is just D. You could write this out explicitly if you wanted, or you could just say it's D. Similarly, what's in both the empty set and D? Well, nothing's in the empty set, so nothing can be in both of these sets. Empty set. All right. What is in C or everything? What's in C or omega? What's in C or the domain of discourse? What happens when we combine these two things? Well, C, by its very nature, is a subset of omega. Every set is a subset of the domain of discourse. So there's nothing new. It's just all of omega. We go the opposite way. What's in both C and omega? Just the elements that are already in C. What is in C that's not in D? Well, remember, these are the things that are in both. We will have to write this one out. So 1, 3, and 5 are in both. So we need all the elements of C that are not also in D. So we can't have 1, 3, or 5. We subtract 1, 3, and 5 out. We're only left with 2 and 4. That's what happens when you take C, 1 through 5, and get rid of the stuff that's also in D. C complement is all the natural numbers that are not in C. Remember, you could write it as N minus C, the domain of discourse minus C. But let's be a little bit more precise. It's all the natural numbers that aren't between 1 and 5. So it's, 6, 7, 8, and so on. C cross D we're going to do on the next one. And again, we're not going to do all of them. A Cartesian product is just all the ordered pairs. So it's going to be 1, 1. It's going to be 1, 3. It's going to be 1, 5. It's going to be 1, 7. It's going to be 2, 1. It's going to be 2, 3. It's going to be 2, 5. It's going to be 2, 7. And so on. Okay. So just write down the notation because that's important, right? It's 1, 1, 1, 3, 1, 5, 1, 7. It's also 2, 1, 2, 3, 2, 5, 2, 7. It's also 3, 1, 3, 3, 3, 5, and 3, 7, and so on, right? It does that with 4 and it does that with 5. So question. If we did a Cartesian product, and I didn't actually check whether this is the case here, it is the case. Remember that sets don't have an order. And sets do not have duplicates. So is it correct that I wrote down 1, 3, and 3, 1? Is that correct? Or is that an error? Should I get rid of one of them? Does it matter? What do you think? Well, it's true that sets don't have an order, but ordered pairs do have an order. So they both do belong here. We did not make a mistake. Now, could we have written 1, 3 down here and 3, 1 up here? Absolutely. The order in which we write these ordered pairs doesn't matter as long as the ordered pairs themselves are ordered. So again, it doesn't matter where 1, 3 goes, but 1, 3 is different from 3, 1 as an ordered pair. So a little bit more trickery for all you guys, some more of the subtleties going on here. Okay, so let's do one more example in this video, and then we'll move on to set operations. Set laws. Anyway, here we go. Let's introduce some new sets. Let A be the set of fonts. And I want to keep things simple. We're only looking at 2 fonts, Arial and Cambria. Let B be 2 styles, bold and italics. And the question is, or 2 questions. Let's say this is part A. What does A cross B represent? So don't just give me A cross B. We can take the Cartesian product, you just do all the pairs. And it might be helpful to do that to answer the question, right? We'll have Arial in bold, we'll have Arial in italic. We'll have Cambria in bold and Cambria in italic. That's going to be their Cartesian product. What does that refer to? What does it represent? Well, if these are the possible fonts and these are the possible styles, then their cross product is all the possible combinations, right? All the possible things that could appear on this like website or Word document or something like that. Okay, I'm not going to write that down, but that's the answer. And letter B is, what is the cardinality of A cross B? And again, this one we can count individually, but remember we also have the shortcut. It's just how big is set A times how big is set B. 2 times 2. The answer is 4. So A and B is, again, set of all the ordered pairs that goes from A to B. A is like our X's, B is like our Y's, and the cardinality is the size of that set, which is going to be 4 here. That's pretty much it for this extra practice video. Hopefully it was helpful. Let me know if you have questions or if anything doesn't make sense, or if somehow, woe is me, I made an error. It's going to happen. It will definitely happen. So please tell me if you do see one. Have a great rest of your day. Hope things are going well. And happy mathing or computer sciencing, as the case may be.